So we'll be discussing today some good questions on the topic of collisions. So when do we say collision happens in physics? Whenever there is a transfer of momentum. So when one body collides with another body and there is a force between them, the momentum of individual body will change according to Newton's laws. Yes or no? So when two bodies collide, there is a force on each other, the contact force, and because of that force, there will be a change in momentum for individual bodies. Total momentum of the system will not change if there are no external forces, that you remember. So let us start with a very simple example. So imagine I have body 1 and body 2. So this is moving with velocity u1. This is moving with velocity u2. Okay. And if you want this to collide with this, u1 should be greater than u2, isn't it? Now let's say here they collide. This is just before collision, okay? Just before collision. Just before collision. So the velocity is still u1, u2. Okay, just before collision, velocities are still u1, u2. Then what will happen now? Forces will start acting. From Newton's third law, we know the magnitude of the forces will be same, right? Then what will happen is this deformation of these bodies will start taking place. What will start taking place? Deformation. So because of the force, the shape of the body may change. Let us assume they are elastic bodies, okay? So something like this. So here what has happened, the shape of the body has changed. So here they get compressed. So because of this force, this velocity of first body will decrease or increase?
Decrease.
Decrease. And because of this force, velocity of this body will increase. Because this force is in the same direction of velocity, right? So this velocity will decrease, this velocity will increase. There will be a time when both of them will have common velocity. This is the common velocity. During that time, the compression here will be maximum. Right now, I don't care about whether it is elastic collision, inelastic collision, perfectly inelastic collision. I don't care about that. This is just an example of collision between two bodies. So in reality, this is what will happen. So there will be some deformation of the bodies. And here compression will be maximum. Because till this point, the compression is maximum means what? They will have common velocity. This part you understood? Why they will have maximum compression at this state? Let me explain with this spring example. Suppose you take a spring, here is one block, here is one block. Suppose this block is moving with 10 meter per second, this block is moving with 2 meter per second. Quickly tell me, the spring will get compressed or elongated as time passes?
Compressed.
It will get compressed because this is moving faster. This is moving slower. So compression will increase. Now, as compression will increase, remember, spring force will exert force on the block this way. Right? When springs are compressed like this, spring force on the two ends will be like this. Because of this force, this block will slow down. Because of this force, this block will start moving faster. However, still this is moving more faster than this, so compression will continue. After some time, it may look something like this. As I told, this is because of this force, this will slow down. So let's say this became, from 10, it became 7. And from 2, it became, let's say, 5. Okay. Tell me now, compression will continue or it will stop? Here,
Will continue.
compression will continue because this is still moving faster. This is still moving faster than this. So compression will continue. So force is still here. So this force will decrease this speed. This force will increase this speed. Then a time may come when they will have same speed. At this moment, what will happen now? Now your compression will stop. So from here to here, compression continued. Here compression will stop because they have same velocity. Two ends are moving with same velocity means this gap will not change. Correct? So here compression will be maximum. Here compression will be maximum. That is what I was explaining here. Understood? After that, what will happen? This force is continuing to act this way. As long as there is compression, force will be this way, remember. So this force will further decrease this speed. So this force will further decrease this speed. It may become, let's say, 4. And now this force will increase this speed further. So it will become 8. 8 or 7, whatever it is. Now tell me what will happen.
Elongation.
Now elongation will start. Okay. That means here potential energy stored will be maximum. And sometimes they will ask you what is the maximum potential energy stored here. Maximum potential energy stored. How much? Very simple. What was the initial kinetic energy for this system? What was the initial kinetic energy? Half m1 u1 square plus half m2 u2 square. This is the initial kinetic energy of the system. Once they have common velocity, what is the final kinetic energy of the system? Half, since they have common velocity, they will move together. So you can consider this as one body with mass m1 plus m2 into v common square. So this is the final kinetic energy of the system. This is the initial kinetic energy of the system. So the difference, that will be the energy stored in the bodies when the compression is maximum. So this is the maximum potential energy stored. If they ask in exam. Of course, you will think, sir, how to find V common? V common can be found from conservation of momentum. So this is LCOM, law of conservation of momentum. Initial momentum of the system was m1 u1 plus m2 u2. When the compression is maximum, what is the final momentum of the system? m1 plus m2 into v common, right? So from here, you have to find v common, then substitute that here. Okay? Okay, now what will happen after that? So remember, forces are acting. By the way, here, the force acting between them, that force will reach maximum because compression is maximum. After that, what will happen? Now these two will start separating because this will move now faster than this. Remember, there is no spring here. Okay. So now this will move faster than this after this moment. So next diagram, 2 will move with velocity v2, 1 will move with velocity v1. So normally what happens when we do board syllabus, we don't discuss about this part. Yes or no? We just discuss about initial system and then we discuss about final system. Now students, it is possible that from here to here, whatever potential energy was stored will come back to the kinetic energy of the system. It is possible. If that happens, then kinetic energy of this system and this system will be same or not? See.
Yes, sir.
See, obviously kinetic energy of this system is more than this because here potential energy is stored. So kinetic energy of this will be always less than this. But there is a possibility that kinetic energy of this and this can be same. Okay, these two. If the body regains its kinetic energy from the potential energy stored. So whatever maximum potential energy was stored, if it is given back to kinetic energy. Well, in reality, that doesn't happen, you know. Sometimes the shape of the body will be permanently changed, isn't it? When two cars collide, God forbid, but if two cars collide, then after collision, it's not like tuck, they will collide and shape will change and again shape will come back to normal. That would be a fantastic world. And some of that potential energy stored here will go into heat. That's why sometimes if that heat is too high, the petrol or the whatever fuel you are using, it may catch fire, right? So if this kinetic energy and this kinetic energy are same, then we call it elastic collision. So elastic collision means the final kinetic energy of the system equals initial kinetic energy of the system. Okay, that you remember. And for inelastic collision, the kinetic energy final will be less than initial. Acha, if somebody says like this, in elastic collision, kinetic energy of the system remains conserved throughout the collision. Throughout the collision. True or false? Kinetic energy of the system remains same throughout the collision if they say. True or false?
False.
False. Because here you can see kinetic energy of the system was lost into potential energy. It is only after the collision is completely over, then kinetic energy of the system will be same as kinetic energy of the system before the collision. Okay, please make a note quickly. Here, what was the interaction force? Zero. They are not in contact. And here also the interaction force is zero. By the way, in physics, they don't need to really, be in contact in order to collide. Collision is a general word used whenever there is transfer of momentum. So if there is a nucleus, an alpha particle is coming like this, then also the nucleus will exert force and its momentum will change, right? We have studied this in our atoms chapter. So this is also collision in physics, okay? The force time graph of this during this collision will be something like this. So as I told, force was zero before collision, force is zero after collision. And when compression is maximum, that time your force is maximum. During this time, this is the time before this moment. Okay, and during that time, what was happening? Deformation was happening, right? So this is called deformation period. And during this time, this is the time after this, when they will start separating. So that is called reformation period. Reformation. This area will represent impulse. I hope you know force. Area under force time graph is impulse. So this impulse is By the way, students, we will be denoting impulse with J, okay? Because capital I we want to keep for moment of inertia. So this is impulse during deformation, this area, and this area which I have not shaded, that area will be impulse during reformation. Let us try to see what will be the formulas for this impulse. So again, I have to go back to that. So this was traveling with velocity u1, u2. Then during this period, when the deformation was maximum, the compression was maximum, they had common velocity. And then once they separate, their velocities are v1, v2, right? So this area means impulse, as I told, and that is change in momentum. Change in momentum from where to where? From the moment they touch till the moment the compression is maximum. So if I choose the first particle, what will be change in momentum? m1 v common minus u1. Understood this part?
Yes, sir.
Okay. From here to here. Okay. Just be, when they just touch, that time to still they are traveling with same velocity. After touching, then forces will act, then velocities will change. One will move slower, one will move faster, and then they will reach common velocity when the compression is maximum, right? So change in momentum for first particle will be m1 v common minus m1 u1. Okay. So when they collide, let's say here, the impulse will be equal in magnitude but opposite in direction. So impulse on first particle is this side. So I should have put minus sign here. Be careful about that. Huh? This is the magnitude only. This is only the magnitude. So you have to put minus sign because impulse on first particle, if I choose, is this side. Force is this side. So impulse will be this side. And this impulse momentum theorem, this is called impulse momentum theorem, will be very important in collision topic. I can write the same impulse for second particle. JD equals to, for second particle, what is the final velocity? V common minus U2. So similarly, during the reformation period from here to here, this is this period from reformation period, what will be impulse during reformation if I choose first particle? First particle is feeling impulse this way, remember. That will be m1 v1 minus v common. And you can also use second particle to define the same impulse because same impulse is acting on both the particles. Only difference is one is action, other one is reaction. So for second particle, what is the final momentum? m2 v2. Initial momentum m2 vc, m2 common. Okay. Now students, v common already I told you here. So if you get time, okay, if you want, you can spend time to solve these equations. You will get a very interesting formula. Magnitude of impulse during reformation divided by impulse during deformation. This is always equals to v2 minus v1 by u1 minus u2. You can try to show that, okay? And by the way, this is what is called coefficient of restitution. Coefficient of restitution. So check if you can prove this. Only v common we need to substitute. And you can equate. These two are minus of each other, right? So equate and try to see what you can do. So let us talk about coefficient of restitution now. This I gave you so that by chance if they ask in exam, you should be able to tell in terms of impulse. For us, what is more important is if this body is moving with velocity u1, this body is moving with velocity u2, and if they are supposed to collide, then obviously u1 should move faster than u2. First body should move faster than second body. So what will be velocity of approach? Velocity of approach means if you sit here, you will see this approaching with what relative velocity? u1 minus u2. Correct? This should move faster than this. So will be a positive number. And after collision, they have to separate. Separate means this gap should increase, right? From this position when their compression was maximum. This diagram, I hope you remember. From that to this, they have to separate. That means if you sit here, you should see this going with what velocity? v2 minus v1. So velocity of separation will be relative velocity of this with respect to this. So v2 minus v1. And coefficient of restitution is defined as velocity of separation divided by velocity of approach, which is v2 minus v1 by u1 minus u2 as I have told here. Okay. So for elastic collision, E is 1. For perfectly inelastic collision, E is 0. E0 means what? V2 and V1 will be same. So you can think they will stick, but that is not a very nice way to think. There is an example where the two bodies may not stick, but still E is 0. Okay. So I'll try to remind me about that in the class. Okay. If I forget, but I'll tell you later. So there is an example where they may not stick, but still coefficient of restitution is 0. And then for normal inelastic collision, which is not perfect, E will be greater than 0, less than 1. Now, here the velocities where you see along the line of impulse. So wherever the impulse will act, velocities are in that line only. But that is not always true. That then what will happen? Then how to define impulse? That also we have to see. What I'm trying to say is when these two will collide, impulse will act this way because this impulse is due to basically the normal force, and normal force will act perpendicular to this tangent, common tangent, right? So here only normal force will act, right, students? So this impulse is basically due to what? Normal force. So you can write it as, what is the definition of impulse in terms of force? Integral of f dt. So that f here is normal force. If you assume if there is friction, then here also there will be some impulse if there is friction. But most common collisions they will give is without friction. Today we will try to do one problem where there is friction also. So this is basically impulse due to normal force. Okay. So when this happens, no problem. That time we can define this way. But sometimes to students, what will happen? The velocities of the bodies are not along the normal, meaning they are not along the impulse, wherever impulse will act due to normal. So then how to find E? Let us discuss that quickly. So let me give you one beautiful example. So imagine here is a spherical body. It has velocity u1. And here I have another spherical body, identical you can think. It is traveling with velocity u2. And let's say u1 is greater than u2 so that this will catch up. When they will be about to touch, like this it will be. Am I right? When they are about to touch. So you can see this one has velocity u1 here, this one has velocity u2 here. This is the common tangent, so this is the normal. So though you have u1, u2, you can see this u1, u2 has no role in bringing the two bodies closer along this line. So along the normal, these velocities have no component. In other words, we really don't need to say they collided here. They just went like this. Yes or no?
Yes, sir.
Mm. So these velocities are not important when you define coefficient of restitution. See, u1 is there, u2 is there. So in the formula of E, you know there is v2 minus v1 by u1 minus u2. So you may think you will substitute this u1 and this u2. But no, you need to find components of this velocity along the common normal. And here these two velocities have no component along the common normal. So you can't define E. That's because there is no collision. If this is one body here traveling with velocity u1, let's say another body is here, not exactly here, okay, then it will be then it will be head-on collision. Head-on collision means the line of initial velocities are same, or the velocity of this one, that velocity will pass through the center of the second body. That is called head-on collision, head-on. But let us say one body is here. So now when they will collide, just before collision, the second body is, let's say, here. Understood? Traveling with velocity u2. So this is your common tangent. So this is your common normal. So let's say this angle is theta 1, this angle is, in this case, same only, right? Whatever it is. So what you have to do is you have to find component of this u1 in this direction. Let us call that u1n, and component of this velocity in this direction, u2n. And same thing you have to do for final velocity. So after this one will hit, this may go this side, this may go this side, and this may go somewhere here, or maybe somewhere here, and this may go somewhere here, let's say. So you have to draw the common normal and then take components of this. One here, one here, one here, one here. Well, these ones are not important for us to define coefficient of restitution. We need these two. So if this is V1, V2, this is V1n, this is V2n. So basically, how will you write coefficient of restitution? General case. General case, you will write V2n minus V1n divided by U1n minus U2n. Same formula you use, just put n everywhere so that you will remember you need to take the components of velocity along the common normal. Okay? This one I don't think you need to do. This one you do, you'll get idea. And if angles are known, then obviously you can find if this is theta, what will be this? U1 cos theta. That you know already. So let's say you have a floor and there a ball of mass m is falling from a height h. Okay. Now just before colliding, its velocity you all know u1 is root over 2gh from kinematics. Here the second body which is colliding with this body, this is our first body. Second body is the floor, and floor is very big. So for floor what will happen? Initial velocity will be 0 for the floor. In fact, after collision also, final velocity of the floor will be 0. Then after collision, let's say it goes back, it starts with velocity v1 and it goes up to height, let's say h dash. Then from maximum height formula, you know, this is v1 square by 2g. That means v1 will be what? Square root of 2g h dash. Now here, this is your common normal because this is your common tangent. This is the ball, this is the floor. So this is your common tangent. So this is your common normal, right? You can see velocities are along the normal only. So we can use our old definition of E. V2 minus V1 by U1 minus U2. So what is V2? V2 and U2 are 0, I told, because the second body here is the wall. Sorry, the floor. It could be wall if it is hitting this way. And therefore, V2 will be 0, U2 will be 0. What about V1? V1 is up, remember. So let us take up positive. So root 2gh dash. And what is U1? Down. So down we will write negative minus root 2gh. This is 0. So root 2g cancel, minus minus cancel. So your E will come under root h dash by h. Okay. So if they give you the height up to where it goes and the height from where it starts, you can calculate E. If the heights are same, let's say, after colliding, if it goes back to same height, then obviously E will be 1 and that will be your what collision? Elastic collision. Also, this formula, here you try to see separately. This is in terms of height. Let us write in terms of velocity only. So E will be V minus V1 by U1. So V1 will be what? Minus EU1. That means if a ball hits normally with velocity 10, it will rebound with velocity E into 10. Sir, minus, that is because of direction, don't worry. So if a body hits with velocity minus 10, put minus 10, it will rebound with what velocity? Plus E into 10. That please try to remember. So if something hits with velocity V, it will rebound with velocity E into V. There is a floor and a ball is coming at an angle theta with the normal. With velocity u. Okay. Mass is m. And after colliding, it goes, let's say, at angle alpha. And it rebounds, not velocity here, okay, actually, just after. Are Baba, gravity will be there, no? Then after, once it rebounds with that velocity, it will go in projectile motion. So this is, I'm not saying here velocity is u like that. I'm saying just before hitting velocity is u. But if I show here, it will be very difficult to take components and show the diagram. So a body hits with velocity u, or think gravity free space best. So after hitting, it will rebound at what angle you have to calculate and with what speed also. So with what speed it will rebound and what will be alpha. Answer should be in terms of u and theta. U and theta are given. Okay. And coefficient of restitution is E. Try this as numerical also. Choose 30 degree, 10 meter per second. E you choose half and find V and alpha. Assume the floor is smooth. Try once. So what you have to do, you have to take components now. So this is theta, so this will be theta, so this will be u cos theta, u sin theta. Remember, which is the velocity along the normal? So which velocity is along the normal? U cos theta. So this is the one which will come in the formula of E. I told you. I hope you remember, right? You have to always write velocities along the normal to find E. So this V will also have two components. Let's say here Vx and here Vy. So immediately from our previous knowledge, we can write Vy in magnitude will be E times u cos theta in magnitude. Yes or no? I don't know
Yes,
if, yeah, if it hits like this with velocity 10, it will rebound with velocity E into 10. Forget about this component because E formula has only velocities along the normal. If you want to write formula also, you can write V2n minus V1n U1n minus U2n. Here velocity of second body is 0 because second body is Earth. Earth is at rest before and after in this frame of reference. And V1n is this, V1n is this Vy. And U1n matlab velocity of this along the normal, that is minus u cos theta. So what will be Vy? Eu cos theta. Okay. Now, how will you get to find V? We need Vx also. Any idea how to find Vx? Anyone? How can I find Vx? Vy I found from coefficient of restitution. Vx how I can find? Yes, we can use conservation of momentum, but Bhadesh is saying LCOM, but LCOM if you say you have to tell system also. So here you cannot choose Earth and body as system because Earth's mass we can't include in this problem. So obviously we are not talking about conservation of momentum of Earth and this particle. So we are talking about conservation of momentum of this particle. But how momentum will be conserved for this particle? Because when it strikes the floor, there will be a force, normal force. And if there is a force, how is momentum conserved? Very good. So along y-axis there is force, right? When the particle comes and hits the floor, on y-axis there is force, normal force, isn't it? Contact force. This is your impulsive force. Impulsive force. So suddenly when the ball will hit, it will feel large force in short interval of time. In such short intervals of time, gravity can be neglected, I told you, because gravity is a constant force and time of collision is very small. So impulse is what? Force into time of collision or integral of dt. For constant forces, you can take it out. And since time of collision tends to 0, impulse due to constant forces like gravity will be 0. So constant forces we will not treat as impulsive forces. So we will not worry about gravity. Anyways, gravity is along y-axis in this problem. But along x-axis there is no force. So along x-axis there is no force because they told it is smooth. That means along x-axis there is no force on the ball. Therefore, we can conserve momentum of the ball along x-axis. Or mass is same, so directly you can say velocity along x-axis will remain same. So Vx will remain same as this ux, which is in this case u sin theta. So now V will be what? Under root this square plus this square, right? So E square u square cos square theta plus u square sine square theta. You can take common and then you will get the answer. So we got. What about alpha now? How to find? This alpha is same as this alpha. So tan alpha will be Vy by Vx.
So it's Vx by Vy.
Oh yeah. Thank you. Because this is alpha. So if I draw the right angle triangle, this is alpha, right? So this is your opposite side, which is Vx. This is your adjacent side, which is Vy. Who told?
Sir, like yeah.
Okay, good. So this is Vx by Vy. So Vx is u sine theta divided by EU cos theta. So u sine theta divided by u cos theta will be what? Tan theta divided by E. So this is your alpha. What will be alpha? Tan inverse tan theta divided by E. Did you notice that if it was elastic collision, E equals to 1, what you will get? E equals to 1. Alpha will be theta, and here E is 1. So u square common, cos square theta plus sin square theta is 1. So V will be U. And this is what we have been assuming in previous chapters also, that if a body collides with a floor elastically, it will rebound at same angle with same speed. A smooth spherical particle of mass 1 kg approaches a rough horizontal plane with speed 10 meter per second. So this is a rough horizontal plane and it approaches at an angle 45 degree with the plane. So with normal also 45 degree. The coefficient of restitution is 0.5 and coefficient of kinetic friction is 0.2. You have to assume slipping throughout the assume slipping throughout contact. So during contact, you have to assume there is slipping so that friction will act. You have to now find the angle alpha. How to do this one now? Let me show you. So when the ball will strike the floor, it is coming this way, remember. So it has tendency to go here. So friction will act on the ball this way. And there will be normal, right? So if you again take components, so this is 10, this is 45. So it will be 10 by root 2. This will be also 10 by root 2. And this is, let's say, Vx. This is Vy. Now Vy we can do the same way because COR is given, right? So Vy will be E times Uy, which is 10 by root 2. E value is half 10 by root 2. So this is 5 by root 2. So good news is at least we got Vy. Now we have to find this Vx. Now Vx now we cannot say is 10 by root 2 like before. Then what to do now? So this is where impulse momentum theorem will be very, very useful. So let us use impulse momentum theorem. What it says, impulse is equal to change in momentum. So due to normal force, what will be impulse? Jn, let me write. Remember, normal force is up. Let me take up positive, right side positive. Keep your sign clear, okay? Otherwise, you will get wrong answers. So impulse is up, so positive is equals to change in momentum in y-axis. So this is m into change in momentum along y-axis you tell. Mass I already wrote, so write change in velocity along y-axis. What is change in velocity? Vy is up minus 10 by root 2 is down, so minus 10 by root 2. I hope you all are clear about this. You have to be very careful with sign, guys. Otherwise, unnecessarily you will lose marks. So final momentum is up, initial momentum is down. So while substituting for initial momentum, I should put minus. This minus is by default in change in momentum. Mass is given 1, so this will be Vy plus 10 by root 2. So you may think, sir, okay, Vy we will try to find from here, but I created one more unknown. Then what to do now? Well, let us write impulse along x-axis also, because this friction will also create impulse. So impulse due to friction will be mass into change in velocity along x-axis, and impulse friction is left side, so minus. Friction is this side means impulse will be this side. Impulse is force into time, bro. So wherever is force, impulse will be there on the ball. M into M is 1. Vx. This Vx is positive minus this Ux is also positive. But then I created Vx though we want. What's a Vy we know, right? Let us substitute this Vy here. So Vy is 5 by root 2 plus 10 by root 2. So 15 by root 2. Right? So now students, what to do with Vx? Can we connect J of normal, impulse of normal with impulse of friction? Yes, because it is kinetic friction. So F will be what? Mu into N. So if you multiply with time, you will get impulse of friction will be mu into impulse of normal, isn't it? Friction into small interval of time, mu into N into small interval of time. Force into time is impulse. This is impulse of normal. This is impulse of friction. So we can connect this two by this, okay? We can connect impulse of friction and impulse of normal with this formula. So from here, what will be JF? Positive if I write, that will be 10 by root 2 minus Vx. Okay, let me make it positive so that no confusion happens later. Now tell me JF, 10 by root 2 minus Vx. Mu was given how much? Check.
0.2, sir.
0.2. And J due to normal we already found 15 by root 2. So this is 10 by root 2 minus Vx is equals to 0.2 into 15. 2 5s are 10, 0, 1, 3 by root 2. So Vx will be simply 7 by root 2. Right, students? So now once we got Vx, Vy, we are done. So tan of alpha will be what now? Be careful, opposite is Vx. So Vx we got 7 by root 2. Vy was 5 by root 2. So this is 7 by 5. Okay. A ball having mass m and velocity u makes a head-on collision with another ball. Head-on collision means this U will be along the line such that that line will pass through the center of the second ball. About this, no information is given. No info. No information is given about the second ball. After collision, velocity of ball of mass m was found to be v in the original direction of motion. So this is before. After collision, the body with mass m was found to move with velocity capital V in the same direction. The interaction force between the two balls during their collision has been shown in the graph. So the force that exerts between them when they collide, it is shown like this. The area of the shaded part of the graph is same as area of the not shaded part. So this area is same as this area. Areas are same means what here? Impulse during deformation is same as impulse during reformation. Find the velocity of the balls at the instant they were having equal velocity. So at the time they have equal velocities, we have to find that velocity. So as I told, a moment will be there before and after. This is before, this is after. In between, there will be a moment when there will be some deformation, right? And they will have common velocity. That common velocity they are asking. Now, if areas are same, that means impulse is same. So impulse, this is impulse during deformation. So impulse during deformation, you tell. M. Remember, for this we have no information. But for impulse, we need change in momentum. Change in momentum means for one body, no? If my height changes, then it is change in my height. My height minus your height is not change in whose height, I don't know. So what is change in momentum of the first ball? M into Vc minus this U. Similarly, impulse during reformation, and that impulse on first ball will be this way, remember. So both impulse on the first ball, impulse is always this way, right, during collision. And this is impulse on the second ball. So what is impulse during reformation? Change in momentum from here to here. Now from here to here, second one we have no idea. But we don't need second one's information. First one's information is enough. So first one's from here to here, this is final, this is initial. So it will be M V minus Vc. This part is clear. This is change in, this is impulse during this part. This is impulse during this part. During this part, impulse is called impulse of deformation, which is from here to here. From the moment they just hit till this moment. And this is impulse during reformation period, which is impulse from here to here. So you can use the first body and calculate change in velocity from here to here, Vc minus u. That is your deformation part. And from here to here, change in velocity is what? V minus Vc. Now you can equate these two. Why we can equate? Since areas are same. Because areas are same, these two impulses are same. Basically, it is a what collision? Elastic collision. So JD must be equal to JR in magnitude. So if you equate, what will you get? M will cancel. Vc minus U, V minus Vc. So 2Vc will be U plus V. So Vc will be u plus v divided by 2. That was given, right, in our question. U and v was given. If two equal masses collide elastically head on word is important, then they will simply exchange their velocity. Exchange their velocity. So if two equal masses collide elastically head on, they will exchange their velocity. If it is not head on, then assuming u2 is 0. u2 is 0 means velocity of second body initially is 0. You will see v1 will be perpendicular to v2. The proof of this is there in NCERT textbook. You can check. If you want, I can prove it some other day, but this is something you need to remember. What this means is, here is a, let's say, carom board. You have put some coin and you strike it not head on here with velocity u. If the masses are equal and it is elastic, then you will see after collision, if this one goes here, this one, let's say this is shaded part, this will go exactly here. So this is always 90. So sometimes they will give you this angle 30 degree, they will ask this angle. Don't waste time using LCOM and all. Directly, right, okay. So these two things try to remember. See this question. A ball of mass m is traveling with velocity 3 meter per second and there is a wall which is moving with 3 meter per second left side. This is wall, okay. Mass of this wall is very, very large. So you have to find velocity of ball just after collision. Try once. Don't think of LCOM because mass of the wall is not given only. And the collision is elastic. Collision is elastic. Try this problem. So this is the picture before collision. After collision, what will be the picture? Because wall is too heavy, you will assume wall will continue with what speed? Same speed. Because wall is very heavy. And particle is going with what speed? That we don't know. Now tell me what is velocity of approach, relative velocity of approach. If you sit here, you will see this coming with what velocity? 6. How 6? Velocity of ball minus velocity of wall, which is this side, so minus 3. What is velocity of separation? If you sit in the wall, you will see this going with what velocity? V minus 3. Now, what is E definition? Velocity of separation by velocity of approach. Separation velocity is V minus 3. Approach velocity is 6. Since it is elastic, E will be 1. So V will be 9. Understood this problem? Or you want me to show using this formula? V2 minus V1 by U1 minus U2. This formula if you use also you will get same answer. What is E1? Just think carefully. Who is V2? First is decide who is 1. This is 1, this is 2, let's say. So who is V2? 3 this side. So minus 3. V1. V1 means this V this side. So minus V. U1. This one, this side, plus 3. Minus U2, this side, minus 3. So this will be 6 cross multiply minus 3 plus V. V will be 9. Same answer or not, guys? Understood or not? This way also.
Understood.
Now, a very smart way to solve this problem is not this way. What you can do is, look here, just sit here. If you sit here, you will see this going with coming with what speed? 6. And whenever there is a huge mass at rest, like a wall, a ball coming and colliding elastically will go back with same speed, provided it is rest wall. So if you sit here, this wall will be at rest. So for you, this ball will go with what speed? 6. Now with respect to ground, what will you do? Add that 6 with speed of the wall. So you'll get -6 here, 3 here, -3, you'll get -9. So that way also you can do the problem. Okay. So velocity of ball with respect to wall will be 6 this side. Then what we have to do? We have to add to this to find velocity of ball. We have to add to this velocity of wall. So velocity of wall is this side. So you will get answer in magnitude will be correct. This will give you direction also correct. But here direction already I have written. So I just wrote the magnitude as V with minus sign. Now this idea is very useful in this classic problem. There is a big, you can think of basketball, which is dropped from a height of h. On top of basketball, there is a small ping pong ball. Okay. If this is M, this is capital M, you need to assume this is way, way larger. So after collision with the floor, with the ground, so after collision with the ground, find velocity of ping pong ball. This is your ping pong ball. Ping pong ball matlab the table tennis ball. Okay. So what will happen here? Let's say they are coming down like this. When they are about to hit the ground, just before hitting the ground, the whole system has fallen height h. So they will have velocity, let's say u and u. That u will be what? Root of 2gh, remember. And also find height to which it goes. It matlab the ping pong ball. Up to what height it will go. So till here I hope you understood. Now just after collision, here, this will reverse. Wall is very big. Sorry, the floor is very big. So this will just reverse the speed. And this is still at that moment coming with speed u. Then what will happen? This will continue with u, because just now I discussed with you when very big mass will hit small mass. Big mass will continue with same speed. And this one will go with what speed? 3 times u. How, sir? See, if I sit here before collision of between these two, see students, first collision occurs with the floor. Okay, then collision will occur with the ping pong ball. Ping pong ball and whom? The basketball. Think of this as basketball. So if you sit here, you will see this coming with what speed? 2u. And after collision, it will become 2u up. That is relative velocity of this ball with respect to this big ball. So 2u up. Now you have to add velocity of ball, which is u only. because after collision also ball will go with u speed because it is too big compared to ping pong ball. So 2u up, at velocity of ball u up, it will become 3u. Otherwise, if you are confused, from here to here, use E formula. E formula. V2 minus V1 by U1 minus U2. I should have told you all collisions are elastic. All collisions are elastic. So, let us say this is first body, second body. So, second body, E is 1. V2, this is initial, this is final. So, V2 will be U up minus V1 is, we have to calculate. Oh, sorry, V1 is final velocity of first body. No, so that is what we are trying to calculate, because I am calling this as first body, this is second body. Okay, u1 initial velocity of first body down, so minus u, u2 u up. So if you cross multiply, minus 2u will be u minus v1, so v1 will be this v1 will come here, minus 2u, u will go there, 3u. Yes or no? Understood? So therefore, because of this speed, now when you go to some speed, up to what height you will go? U square by 2g formula we know. U square by 2g is the maximum height formula. So from the top of the basketball, it will go from there up to what height maximum it will go? 3u square by 2g, which is 9u square by 2g. So the height that it will go, maximum height, will be 9u square by 2g from the top of the basketball. Now, if the size of the basketball is neglected, then you can write mass you cannot neglect, size you can neglect. Then this is the answer. But if they say diameter of the or radius of the basketball is r, then from the ground, if you want to find the height, you have to add 2r. Okay. And this h was given in the question, so u is 2gh. Substitute this u here, so that will be 9u square is 2gh. 2g 2g cancel. Substitute this u here, ma. U square will be what? 2gh. 2g 2g cancel, 9h. So the ball will go up to what height? 9h if you neglect the size of the basketball. And if you include the size of the basketball, then from the ground, 9h plus 2r. Okay. Two particles A and B of equal mass m are moving with speed v as shown in the figure. So this mass m is moving with speed v at angle 30 degree, and another mass m, same mass m, speed is also same, is coming at 45 degree. Here they collide. Okay. So after collision, this is A, this is B. After collision, they stick. They stick and move as one particle C. Move as one particle C. That C is going somewhere here. You have to find this angle theta. This is the particle C. What will be mass of this particle? Obviously 2m. This theta you have to find. Chalo, try. So again, you have to take components of momentum along x and y. So this is v. So you take two components. If this is 30, look carefully. This is also 30. So this will be v cos 30. So v root 3 by 2. This will be v sin 30, v by 2. Similarly, this will be 45 degree given here. So it will be v by root 2, v by root 2. And this one will have two components of velocity which we don't know. So vx, let's say vy. And this theta means, remember, this theta. So let us use law of conservation of momentum first along x-axis. So momentum of this particle initially, this, remember, this picture is before collision, this is after collision. So this is before, this is after. So before, what is the momentum along x-axis for this particle? M into v by 2, right, x-axis. And for this one is opposite direction, so minus m into v by root 2. That must be momentum of this particle along x-axis, that is 2m into vx. So m you can cancel. So vx will be v by, let me write it as 2vx only. So 2vx is v by 2 minus v by root. Similarly, for y direction, apply law of conservation of momentum. Initial momentum for these two particles along y-axis is mass into velocity of this particle along y-axis is root 3 v by 2. Momentum of this is mass into velocity v by root 2. Both are up, so plus. That must be momentum of this along y-axis. So 2m into vy. So if you cancel m, you can write 2vy is equals to root 3v by 2 plus v by root 2. Right? So tan of this angle will be what? Opposite this time is vy, remember. So vy by vx. So if you divide these two, these two will cancel. So vy by vx will be root 3 by 2 plus 1 by root 2 divided by, this is vy by vx, 1 by 2 minus 1 by root 2. I hope you see why this, I did not write this 2 will get cancelled, and this v common will cancel. Okay. Then here you will get 2 root 2 LCM. So this will be root 3 root 2 plus 2 divided by 2 root 2 LCM. So this will be root 2 minus 2. Here if I take root 2 common, it will be root 3 plus root 2, and here root 2 common, 1 minus root 2. Because answer is given this way in the exam. Okay, let me check once. Root 3 plus root 2 divided by 1 minus root 2. Correct only. So two particles are moving in a circle in such a way that at some point A, one particle is going with speed v, another particle with small gap is going with 2v. So they are asking after how many collisions, they will again reach A. Okay, they are not asking you to count the last collision. After reaching it, they are not asking you to count. From here, you count how many collisions will happen before they reach here. And they asked you to take the speeds of the two bodies to be constants. Speeds, okay, not velocity. In circular motion, velocity will change. Can you try once? So what happens here is, you can see this is traveling with double speed than this. That means what? That means this will cover double distance than this before they meet. because when they meet, it will be same time for both of them. So double distance means what? If you divide this into three parts, then by the time this body will come here, v speed body, this body with speed 2v will come here. Yes or no? 120, 120, 120, you can think. This part you understood. In the same time, one of them is traveling with double speed, so it will cover double distance. So double distance means if you divide this into three parts, this one will travel one part, other one will travel two parts. Now, because they are equal, oh, sorry, I forgot to tell you, sorry, the collision is elastic, okay? Collision is elastic. I also forgot to tell you masses are same. Masses are same. Otherwise, how you will do, right? So if masses are same, what will happen after collision? They will interchange the speed. So this will now start moving with 2v and this will start moving with v. That means now this will cover double distance here. This is traveling, this is 2v, this is the faster one, okay? Now this is the faster one. And this was the faster one. After heating, it became slower one. So it will reach here. Then again, after colliding, what will happen? This one will have velocity of this one. They exchange velocity, right? And this one will have velocity of this one. So now this is slower one. So this will reach here. This will again reach here. So they will reach here after how many collisions? Two collisions. Everyone understood? Block A is hanging from a vertical spring of spring constant K and is at rest. Okay. Block B strikes block A from below with velocity v. This is just before hitting. And sticks to it. And B sticks to A. Find V for which spring just attends, just word again, just attends natural length. Okay, so let's do it. So what will happen now is, first you have to know where is the natural length. Okay, so natural length means when the spring is not stretched. So without any block here, whatever length it has, that is the natural length. So try to remember that. Okay. Now that means when this block was at rest initially, it must have already stretched by some amount. Okay, so this extension they have not given. Let me write x naught. Of course, x naught will be very easy to calculate because this is at rest. So k x naught for this diagram, for this part, it is in equilibrium, no, at rest. So k x naught should balance mass of A into G. So x naught will be mass of A is m only, so mg by k. That you try to remember. Then block B is coming from below with speed v. Now, just after collision, remember they become one body, 2m mass, isn't it? And then they will start with what speed? V dash, let's say. Okay, just after this diagram and this diagram is in the same place. Okay, just before heating, and just after hitting. So when they start, they will not start with this v speed, because now they have they are stuck to each other. So it is a perfect inelastic collision. So they will start with some common speed which we have to check. And then what should be this v they are asking, so that they can just reach the natural length. So if you reach the natural length, then it means just reach, it means final velocity here should be 0. So this 0 is because they told just here. Okay. So first what we will do, we will try to find this v dash. So that for that we will use conservation of momentum in this part. So what will I get? This was at rest, so m into 0, plus this was moving up, m into v, that must be equals to 2m into v dash. So what will be v dash? V by 2. Now from here to here, what we should use? Any idea? Whenever velocity is here and here, whenever you know velocity between 2 points and you want to connect them, and you know the body is moving under conservative forces only, that time you can use L Comé. What is L Comé? Law of conservation of mechanical energy. So if I use conservation of mechanical energy between this and this, let us call this as 1 and this as 2. So K1 plus U1 must be equal to K2 plus U2. Here what is the kinetic energy? Half 2m, velocity here is v dash, remember, don't take this v. V dash is v by 2 whole square. Plus potential energy here, how much to take? That is up to you. Let us choose reference here. So this is my reference, okay? If you don't choose reference, then it will be problem, students. So this is where my height is 0. So if this is height 0 location, then here potential energy gravitational part is 0. But it is stretched from the natural length, and for spring potential energy, we choose natural length as reference. So this is reference of spring potential energy. So here there is no potential energy stored, we are assuming. Then here obviously it is stretched by some amount. So there will be some potential energy stored. So what will be that potential energy stored? Half k x naught square, because this stretch is x naught from natural length, equals to, when it reaches here, kinetic energy becomes 0. Here, because it reached the reference of spring potential energy, here spring potential energy is 0, but it is at a height from this reference of gravitational potential energy, right? So that height is how much? X naught only. So it will be plus mg x naught. So this part you guys understood or not, just let me know. So now I think I can substitute for this x naught, right? This 2 will cancel. Mv square by 4 equals to mg x naught. What is x naught? Mg by k. This will go this side, minus half k. X naught square means this square. So m square g square by k square. One m you can cancel, isn't it? Here one k you can cancel. So it will be v square by 4 equals to m g square by k, 1 minus half, half. Did I miss anything? Only. So this will be 2 2s are 4. So velocity will be under root 2 mg square by k.
Sir, 2mg x naught, I think.
Where? Here.
Yes, sir.
Correct. What is potential energy of this part? Mg height. What is m? 2m. This is the main problem. See, that day also I was telling, while writing Newton's law, we have habit of writing acceleration is F by m, but sometimes mass is 2m, but we still write m because we have that habit. So potential energy also we have habit mgh, 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 but mass of this body which is here is not m, it is 2m. M was mass of one of the body. So this will be, where is it now? This will be 2. No, not this, not here. Here I should write 2. So this will be v square by 4 is equals to mg square by k 2 minus 1 by 2. So that will be v square by 4 mg square by k LCM 2 4 minus 1. Now it will come 2 2s are 4, cross multiply under root 6 mg square by k. So this problem is similar to the previous one. What we will do is, we common problem, there is a block of mass m hanging and a bullet of mass m will come with velocity u. It will strike and then they will stick. They will stick to each other. Let's say this is capital M. So once they stick, this system will move together with some common velocity and then it will raise some height. They will ask how much height it will rise. So first what you should do, from here to here you have to use LCOM. So LCOM, fast let us use mu. This is at rest, m plus m into v common. So v common will be what? Mu by m plus m. Then with that common velocity from here to here it will climb some height. So from here to here we will use LCOM. So I have some 5-6 good problems where we have LCOM together. Maybe next time we will try. Okay, no worries. So here what is kinetic? Here it has only kinetic energy, half m plus m v common square. And from here it has gone up to this height. So if I choose height 0 here, there is no potential energy. Here potential energy will be what? M plus m into g into height. And since it has reached up to there, velocity here will be obviously 0. So these two will cancel. So h will be v common square by 2g. V common you can substitute here and you can calculate the final answer. Okay. One question I will not do, but I'll just ask you people. Okay, just asking. So imagine there is a heavy block here at rest on the ground, and here one ball is hanging, one block is hanging, and from here a particle comes like this and hits with velocity u. Let's say these two have same mass and the collision is elastic. Then what will happen? This will hit this one and this will start moving with what speed? This speed. This will stop, then it will fall down. Forget that one after it stops. Forget this one after this hits this one. This will start with this u speed, correct? As it goes up, what will the string exert any force?
No, sir.
No,
It will
sir.
No.
get slack.
No, because as it is going up, the string will become slack. Okay, because this block is there. So it will go like this, then it will come back. Then once it comes back, it is going down with some speed. Whatever, by the way, see, if these masses are same, this will start with the same speed. And then after it hits, after it starts moving, the string will become loose. Till when it will be loose? Till it comes back to the same place, but now it is moving where? Down. And then suddenly there will be a tension force developed. Till that point, tension was zero. So suddenly a tension force will come, a sudden tension force will come, impulsive force will come suddenly, and then these two will start moving with a common speed. It has to be common because this string is inextensible, right? So if this goes up with VC, this will come down with VC. Okay, so this you cannot assume same as this VC. So from here to here, how to find VC in terms of this U, all that we will discuss in some other day. Thank you.